Okay, here we are. We're going to look at some rectangles because remember we're looking at rhombuses and rectangles in this lesson. And is this figure a rectangle? Well, yes, but how do we know? It's a quadrilateral and it has 4 right angles. Okay. Are rectangles parallelograms? How do we know? Opposite sides are parallel to each other, right? So we determined that rhombuses are special types of parallelograms with diagonals that are lines of symmetry, right? That was in our last video. Because rectangles are also parallelograms, let's see what we notice about lines of symmetry in rectangles. Okay, so you need your book, page 26. You can see the magnifying glass there ready for you. All right, make sure you're taking notes. Use a ruler to draw diagonals of the rectangle. So make sure you have a ruler, and of course, I'm going to just do my best to draw it on the computer, but you are going to draw diagonals of the rectangle using a ruler. I'll just do my best straight line. Not such a great line, but I'm sure you can do much better with a straight edge or a ruler. Okay? And then you're going to measure your diagonals and write their lengths. Okay? So you're going to measure from A to C, and you're going to measure from D to B, and you're going to put their lengths right here in the inches. All right? Now, what do you notice about the diagonal lengths of the rectangle? They should be the same measurement. So make sure you measure them. And here you're going to write, they are the same length. And now you're going to measure your 4 angles. Let me get a different color here. You see that you have 4 angles, right? 1, 2, 3, and 4. You're going to measure those 4 angles around the intersection of the diagonals, and you're going to record their measurements here. Okay, so use your protractor. Make sure you're lining up with the bottom line and measure those angles. And are the diagonals perpendicular? Now remember, perpendicular means 90 degrees. So are they 90 degrees? Is that what your measurement told you or not? Make sure you write that in your notes so that when I check your work, I'll be able to see that, right? The rectangle in problem 1 has diagonals that are the same length. What does a parallelogram with diagonals of different lengths look like? It wouldn't be a rectangle, right? Because the diagonals would be different lengths. And it wouldn't have any right angles, okay? Having diagonals that are the same length is a property of rectangles because it's true for all rectangles. Remember, a property means it's true for all. But it is not a property of parallelograms because it's not true for all parallelograms, right? Okay, nice job. Now let me see if I can clear that off. And we're going to go to page 27, which is your next page. And we're going to look at the next. There we go. Okay. Now, number 2, it says another copy of rectangle ABCD is shown. Use your ruler to draw the rectangle's lines of symmetry. All right. Now, remember, we were just working on the rhombus, and the rhombus lines of symmetry were the diagonals. Does it make sense that these would be a line of symmetry for the rectangle? No, that's not going to work. They're not going to overlap. You could try and fold one if you weren't sure about that. Where are the lines of symmetry? Where can you draw a line that will cut it exactly into 2 perfect halves? Right here. See that? We have 2 squares on either side, and also right here. Now mine's not perfect and yours probably not going to be perfect either, but you could see that you could fold the top and the bottom, and you can fold the left and the right side. Sketch a parallelogram without lines of symmetry. Okay, so now we're back to parallelograms, 2 sets of parallel sides, but it's not going to have any lines of symmetry. So let's think about that. Okay, we want to have two parallel sides, but no lines of symmetry. And this is just a sketch, so it's not going to be perfect. Now let's see. Does that have any lines of symmetry? Could I cut it this way? No, that's going to overlap when it folds, right? So same thing for this diagonal. What about down the middle? No, you see how this part's going to be bigger, right? What about this way? This part's going to fold down bigger again. So there is a parallelogram. This side is parallel to this side, and this side, oops, that's not a very good arrow. There we go. That side is parallel to that side, and there are no lines of symmetry, right? Okay. How many lines of symmetry does a rectangle have? 2. The 2 lines through the midpoints of the opposite sides of the rectangle are the lines of symmetry. Do all parallelograms have 2 lines of symmetry through the midpoints of the opposite side? You see what we're saying by the midpoints, right? This line, midpoint through this line of midpoint, this midpoint, right? So halfway through of the line is cutting it in half. Do you see that? Okay. Are they all going to have that? They're not all going to have that, are they? Right? Because this is a parallelogram, right? So they're not going to all be able to cut in half that way, right? Okay. All rectangles have at least 2 lines of symmetry. Does that statement describe an attribute or a property of rectangles? That's going to be a property because it's going to work for all rectangles. Okay. Now we've got some line of symmetry information. Very good. And let's go back to that video we were watching, and then I'll see you on the next video. Thanks for your hard work. Let's clear that off.
And they said, "What a simple and brilliant idea. We get the point." "Now," said Euclid, "let's make another point and join the 2 points together." "Okay," everyone said, "we're happy with that." "Well, when we connect the 2 points together," Euclid explained, "we'll call the shortest distance between the 2 points a line. A line is a thing that has length but no breadth. At each end of the line there is a point." "Yes," everyone agreed, "we understand." "Now I'm going to call this an axiom," said Euclid. "An axiom is something everyone can agree with, a starting point from which we can begin to work out other stuff." "That is so cool," said his ancient Greek friends, or something like that. "Have you got any more great ideas like that?" "Lots," said Euclid, "but that's enough for today. But tomorrow I'll show you what happens if we have 3 points instead of 2.
Okay, so we'll see that in the next video. Thanks for watching.